All right. Thank you for joining us. I don't know if any of you attended the webinar I gave last year. Originally, the class last year was supposed to be a 3-hour in-person class, but because of COVID, it was turned into a 1-hour webinar. And I tried to cover everything in that hour. But getting into some of the earlier parts of the dye process took up a lot of time, and I ended up having to skip over a lot of the plant selection options that people have. So for this webinar, I really wanted to focus on plants that you can forage for dye locally. And these are plants that whether or not you have a yard, you can still probably find them. They're all plants you can find on the vineyard, but even if you're not on the vineyard or not in the Northeast, these are pretty common plants that are sort of ubiquitous. So I will be going over some of the earlier steps like preparing your fabric and mordantine. I'm just not going to go quite in depth. And if you want to have more information about that, you can either refer to my original webinar, which is up on our YouTube page, or there's a lot of resources online, and I'll also share some resources with you at the end of the slideshow. And I'm also available for questions at the end of this. So yeah, I guess I will go ahead and get started. So the dye process, it's a little bit more than just tossing a piece of fabric into a tea for a little while and then taking it out. Although sometimes it can be as simple as that. But no matter where you are in the process, every time you're about to do something to the fabric, you want to make sure that you soak it ahead of time. It's best if you can do it for a few hours to make sure that it's really fully evenly saturated. And the reason you do this is it ensures that it's evenly saturated so that whether you're about to put it into a mordant bath or a dye bath, it'll react to any constituents in the water evenly so that you get an even dye. But it also helps to open up all of the fibers in the fabric so that you get the most saturation and again, an even dye. So the first thing you're going to do is wash your fabric. If it's from the store, a lot of times as it goes through the manufacturing process, there will be certain residues on it that prevent staining, which we obviously don't want because we're trying to stain our clothes in this process. So wash your clothes. Some people will scour things like cotton and other cellulose fibers. It's not really necessary though, unless you're doing it on like a professional level. So you want to wash your fabric. Then you're going to want to mordant it, which I'll get into in the next slide. And then I will go through all of the rest of these steps in separate slides. So we'll go over gathering and processing the dye stuffs, actually making and using the dye, and then curing and washing. So what is a mordant? A mordant is a quote unquote chemical that helps the dye attach and bind to the fiber. So you have different options for mordants and it can depend on the type of fabric you're using. I prefer to use silk because it dyes wonderfully. Wool also dyes really well, but you always have to worry about felting and like temperature changes with wool, which seems like a pain to me, so I just don't use it. And unfortunately, cellulose fibers, you can dye them well, but they're a little bit more work because cellulose fibers like cotton or linen, they don't have the same types of binding sites that the animal protein fibers do. So you can dye them, but it takes more steps to prep them. So whether you're doing silk or cotton, you can use an aluminum mordant. for silk, you would use aluminum sulfate, and for cotton, you'd use aluminum acetate. And it sounds like a scary chemical, but aluminum sulfate is literally sold in the spice section of the grocery store or the pickling section. It's pretty non-toxic. You can pour it down your drain. It's totally fine. Tannins are used sometimes as a mordant for cotton. Otherwise, they're used as a pre-treatment step for cotton before the aluminum bath. Iron can be used as a mordant or a modifier, and a modifier is something that after you dye your piece, you can actually further change the color. And then soy isn't a mordant per se, it's more of a binder. So the soy binds to the fabric, and then the dye binds to the soy, and it's another method that people use for cotton. And I used to do that sometimes, but I get really variable results with it, and sometimes I don't like the way the colors turn out with that. But those are generally your options for mordants. And for the alum, the tannin, and the iron, you can get all of that as a powder. Like I said, either from the grocery store for like aluminum sulfate, or there are a couple places online you can order them. And you basically, for, let's say, just the aluminum, because that's what I use in this webinar to show you all these examples. It's as simple as you basically take a stock pot, like a big soup stock pot, fill it with water. You measure out the amount of mordant that's appropriate for the amount of fabric that you're using. You dissolve it first in a cup of hot water, toss it in the pot, stir it up, toss in your fabric, bring it up to a simmer. You either let it simmer for an hour or you turn off the heat. It just depends on the method you're using. And then you just let it sit overnight. And then afterwards, you want to rinse off any extra mordant that you have on there. Only because if you put it in a dye bath when there's extra unbound mordant on it, then mordant could bind to dye that's not actually going to go on the fabric. It's just going to stay bound within the dye bath. And you can either take something directly from a mordant pot, rinse it, and put it in a dye bath, or you can wash the mordant, the extra mordant off, and then dry it and store it for months, really, before you have an opportunity to dye it. For the modifiers, I mentioned iron. And so iron, it's known to have a quote unquote saddening effect on colors. So it can make the colors just shift to like a darker tone. Or if there's flavonoids involved, which is a plant secondary compound, it can shift a color from yellow to green. It can also turn colors purple or almost black. It just depends on the type of compound that's in the dye. But it generally reacts really strongly with tannins, which are naturally found in many plant parts. And then for pH, if you're using a dye that's mostly anthocyanins, which would be found in something like a viola flower, then you can use either vinegar to shift a blue color to like a pink or a purple. Or if it's already a pink or a purple, you can add something like a base, like calcium carbonate, that will shift it towards blue. And I go way more in depth about that in the other webinar. So I'm not going to touch on it too much right here, but I just want to tell you that you do have options after the dye bath to sort of shift the color. So once you've prepped your fabric, you have it mordanted, and you have it pre-soaked, then you are ready to make and use dye. And I actually, the point at which I start making the dye, if it's not a woody dye and it's something that's like leaves or flowers, then I start soaking the fabric when I start making the dye. But for a woody plant, I might wait a little while, which I guess I'll get into now. So First of all, there are so many exceptions to all of the rules that I'm about to tell you, but it's a good place to start. And generally, you'll get fine results if you follow these rules as I tell you them. So for woody materials like bark, twigs, some dense roots, you'll want to either pare off bark with a carving knife or a paring knife. Or what I do and what a lot of people do, and I think is a lot easier, is to just chop it up into little pieces with like pruners or something. That way you're still exposing the inner bark layer that's underneath the outer bark and the pith. And that inner bark layer is usually really the important part where the dye components are. So you'll want to chop up your materials and then throw them in a pan, like a stock pot, or if you're just testing the dye, a little saucepan with water. And you'll bring that up to a simmer. And then as soon as it hits a simmer, you can turn it off, put a lid on it, and just let it soak either for a few hours or even overnight. Some people will do a few days, but sometimes you have to worry about mold growth at that point. And that just helps it to sort of soak through and start to infuse some of the dyes out without you having to have your stove on for hours. And there's also certain compounds in these dyes that with prolonged high heat might start to deteriorate. So let it soak in that hot water. It'll eventually go to room temperature, but maybe the next day, put it back on the stove with all of the material still in it. Bring it back up to either a low simmer or just below a simmer and let it sit for an hour or two like that on that heat. And then at that point, you're ready to go. And you can either strain out the dye or leave everything in it. It's up to you. And you can put your fiber in at that point. And then I would let it heat up to a simmer or just below a simmer for about an hour. And then turn that heat off and let the fabric sit in there until it comes to room temperature. For flowering, plant tops, leaves, flowers in general, it's a really similar process as to the bark and the roots. You'll want to put your plant material in there, add the water, bring it up to a low simmer or just below a simmer, turn it off, and then the color is going to release a lot quicker than those hard, dense, woody materials. So in a lot of cases, you only need to wait, maybe like an hour or two. It's up to you. You can watch it and just see if it seems to be getting more saturated or not. And then you can either strain it or leave the material in there, put in your fabric, and then it'll need, you can do, it just depends on the dye. You might see results that you like within half an hour, and then you notice as time goes by up to an hour, it doesn't seem to be getting much more saturated. You can kind of play that part by ear. There are some flowers like violets that are a little more delicate, and the dye inside is a little more delicate, which is something that you'll kind of just learn as you go. So for something like that, you might do it like you would make tea, where you heat up water and you pour some hot water on it. And then you just let that sit for a while, and then don't bring it back up to a simmer. Just keep it at a low heat when you have your fabric in there. One thing to keep in mind is the fabric and the dye, they always look darker when they're wet, and they always dry lighter than they look when they're wet. So you might want to leave it in there a little bit longer than you think. So I would wait until it gets a little bit darker than you think you want before you take it out. And then what I do, and what a lot of people do, is something called curing, which means instead of rinsing it right away, you let it dry. You wring out the excess dye, and then you let it dry. And you let it sit for a few days or a week before you wash it. And this just helps. It's kind of like, think about any stain that you get on your clothes. You wash it right away to try to get the stain out, but the longer a stain sits in clothes, the more time it has to sort of really bind in there. So you might want to wait a few days with your, the dye drying on your clothes. Just make sure that you don't let it dry in direct sunlight, because direct sunlight is a bane to some dye's existence. And I think I've about covered that. All right, so these are most of the plants that I'll be going over today. And like I said, these are all plants that you can find here on the island, and you can find pretty much anywhere, at least in North America. There's tons of garden plants, really common garden plants that you can use for dye. I'm sure many of you have heard of people using marigolds and coreopsis for dye. But there's a lot out there on those species already. And I wanted to more focus on something that you don't need to have a garden or steal from someone else's garden to make dye. So even if you live in the middle of a city in an apartment, you can still find a lot of this stuff growing, in waste areas, or, the sides of parking lots or public parks. And you'll see a lot of these are in different categories, and that's because a lot of plants can make different colored dyes depending on what part you use, or what you use to mordant, or what modifiers you use. So I'll be going over that, and each of these will have their own slide. So, before I go to the next slide, actually, I also want to mention that one plant species, and even one individual plant, can end up yielding different colored dye depending on different factors. Time of year, the season can make a difference. The soil can make a difference. Whether it has a disease can make a difference. So do not go into it expecting that you will get the same results twice, because often that's not actually the case. But I feel like personally, it's part of the fun. And also, before I get into the foraging, there are some ethical considerations. So you really should know what the plant is before you forage it. And that's because it could either be rare, which means it could even be illegal to be foraging it, or it could be poisonous, which you obviously don't want to bring harm to yourself. And, even if it's a common plant, but it's a really small population, you should probably just leave it, because there's other creatures that depend on it, and it needs to reproduce itself to stay there. So if you take half of a small population, then you don't want to accidentally extirpate it from that area, especially if it's something that, like pollinators rely on at the beginning or the very end of a season when other things aren't flowering, stuff like that. If it's on private or protected property, you really need to have permission. So if you're on the island and you're on, say, a land bank property, and you see some goldenrod that you want to collect, it's a common plant, but you need to have permission for some of these conservation properties to take any sort of plant part. So just keep that in mind. I really like to forage from like the edges of parking lots can actually be really good places. Even like roadsides, stuff like that. And a good general rule is, even if something is abundant, for every one you take, leave 3. So if there's only one plant and you want to take a few leaves, don't totally defoliate it, but only take a couple of its leaves. Or, if there's like 30 goldenrod plants on a property, don't take 20 of those 30, maybe only take a few. So I just wanted to make sure that everyone is clear that there are some considerations you should take before just going out and snagging a plant. So first, I'm going to talk about plants that you can get red, pink, and orange from. Red and orange is somewhat difficult to get from just like any old plants. The dye compound that's found in the red bearing plants are called, they're usually from anthraquinones, which are in plants like madder root, which is, you know, a historical and common dye plant that you can buy, like madder root powders and extracts to dye with. There's a couple other ones that are evading my mind right now. But there are some plants in that family that you can find growing wild in certain areas. There are always good places to start looking for that. And orange is something that I've gotten by accident from like sumac before, but I've never really gotten it any other way than combining dyes. So in that right picture right there, those top two swatches are willow bark dye, which is that pink color, and then curly dock dye, which is that yellow color. But if you combine the dyes either in the same dye pot or by first dipping in one and then dyeing in the other, you can get that orange color that you see at the bottom. So sometimes combining dyes is a good way to go about getting a color that you don't really have an individual plant around that can yield it. And then that photo to the left there is a willow bark dye pot. So Gallium malugo, that's just one species. You can probably get this dye from other species of gallium, but this species is not native on the island. And so I didn't feel bad tearing it up to use the root. The root is the part of this plant that you use. And there are some native species. So, you know, like I said, if you know, you should try to find out whether it's native or not. And if it's like a small native population, please don't rip it out to use the roots. But if you're weeding your garden or, you know, an area of your property or like a park that you're at has this growing and you know that it's not the native one, you don't really have to feel as bad. And this picture you see here to the right, those two swatches on the left that are that lighter color, neither of those were mordanted. So the one all the way to the right was not mordanted, and it was dyed in the same way as the one right next to it, but it was dipped into iron after. So it has that slightly darker color. And so with this dye, even though I didn't mordant the silk, it was able to pick up a little bit. You can see it's really hard to take pictures of some of these dyes, especially on the silk, because it's so lustrous that it reflects light. But if you see the three swatches on the right of the picture, all of those were mordanted with alum beforehand, and they're this really pretty blush color. This family, or this genus, Gallium, which is the bedstraw, is in the same family as madder root, which I mentioned in the previous slide. So, you know, some gallium species might not have much in their roots and others might. It's just a trial and error sort of game. But you can see this one, even though it responded to the iron a little bit, it really didn't have too much of an effect. And you can see in the mordanted swatches there on the right, the one all the way to the right was modified with iron after, but it didn't really do anything. And sometimes that happens, especially if there's no tannins in the plant, because tannins react really strongly with iron. So some plants you might get a reaction, some plants you don't. It's just, you just got to experiment. Salix willow. I have two willow examples here for you. This is Salix cinerea. This is not a native species on the island or anywhere in the US. And that Gallium malugo too, I believe. Well, actually, I'm not going to say it because I don't want to be wrong. But this willow is not native anywhere in the US, so you don't have to feel too bad trimming some branches off of it. So like I just said, the parts that I use for this would be the wood of the willow. And I prefer, I never take bark off of the trunk of trees that can really damage trees, which in this case wouldn't be a big deal since it's kind of a cruddy tree. But instead of taking bark, I always will trim some branches off instead, or some twigs, as long as they're a bit starting to get some lignification there. And so on the right here, everything was mordanted in alum and then dyed. And then the two in the middle here were dipped in an iron solution. So you can see they're a darker color. And this picture doesn't show it very well, but it's actually like a mauve. It looks brown in this picture, but it's more of a really pretty mauve, almost with I guess with a slight tinges of like a grayish brown in it. But like I said, it's really hard to capture the true colors sometimes, but I do my best. So you might see some wacky backgrounds here, but it's just me trying to find the perfect light to accurately portray some of these colors. So this was a dye made from a weeping willow, which I don't think we even have on the island, but I just wanted to show you just another example. And these two actually, I'll go back, yielded a pretty similar dye. And what's funny is I had made a dye out of these weeping willows, again, with just some branches that I don't even know if they were really alive anymore at that point. This was from my backyard out in Western New York. And the first time I made a dye with it, it was a different time of year, and it was more of like a creamy, just very slight blush. And then when I did it this time, it was much more saturated and almost a little bubblegummy, which you can't see in the picture. So you just never know, and it's fun to experiment. Black cherry, I've got to say that black cherry bark has got to be my new favorite dye. I got pretty dang close to a good red. You can see that one. So all of these were dyed in the black cherry bark dye pot. The two on the left were not mordanted, but because there must be some tannins in that dye, it did pick up a little bit of dye there. And then the two on the right were mordanted in alum, and the one all the way to the right was dipped in iron, so it's a little bit darker. And again, the light is sort of reflecting off of these, so they might look a little bit lighter than they actually are in person. But black cherry is not the only species of prunus that you can get beautiful dye from. Most, if not all, species of prunus will yield some sort of pinky or reddish colored dye. So I just happened to choose black cherry because there was one sprouting out of the ground next to my house. And you can find them all over the island. So, and you know, it's also really common where I've been living out in Western New York. So it's a pretty widespread tree. And even if, you know, a lot of times in the spring, you might be driving by and see people trimming their apple trees. You can always ask people for a few branches. You know, beach plum is another prunus species. I've never tried it, but I'd like to sometime. Hypericum perforatum, common St. John's wort. This is another one that so the black cherry is a native, but it's pretty widespread. So I don't feel bad trimming branches off of it. Common St. John's wort is not a native. We do have some native species of St. John's wort, but you can tell the difference between the weedy non-native one. Hopefully you can see my cursor, but if you can't, there's these little black dots that you will see at the edges of the petals. And also at the tips of the female parts here, the stigmas. And those hold something called hypericin in them, which is where the genus gets its name, Hypericum perforatum. And well, actually, I got that backwards. Hypericin gets its name from the genus. But anyways, I digress. Not all species of St. John's wort contain hypericin like this one does. So it's better to stick with this weedy species anyways. Sorry, my speaker just turned off because no one has said anything. Okay, now I'm done being distracted by that. I had to turn it back on. Anyways, so the hypericin itself gives off a dye, and the part that you're going to want to use for St. John's wort dye is the flowering plant tops. And apparently, right before the flowers are ready to open, it's also really full of dye, and maybe even has more dye than when the flowers are open. So the hypericin and the pseudohypericin that are within the species will yield this really beautiful, rich, reddish brown dye. And there's actually a lot of different colors you can get out of St. John's wort, this species of St. John's wort, because it has just like a myriad of different plant compounds that make dyes. And so depending on what you mordant with and where, like what you've already dyed with that dye bath and which compounds have already been taken out of the dye before you put another piece of fabric in, you can get all sorts of colors. One thing I found interesting is you see the little ribbons on these bags have like a more yellow color to them, but they're both silk and they were both dyed in the same dye bath. And so I don't know, and you can even see the threads on the bag also dyed yellow. So I have no idea why. It must have been something in the manufacturing of this silk that it picked up different colors. But that's just one of the surprises that happens. And I'm going to cover St. John's wort a little bit later in this presentation too, to show you some of the other colors you can get. Sumac is another one. It's another one that you can get a lot of different colors from. And the leaves of sumac hold a lot of tannins, and there's different classes of tannins in plants. And so when it comes to that pre-mordant tannin step I've been talking to you about, sumac leaves are actually a great choice for that because the particular tannins that they have in their leaves have a very, very, very light and to almost no color to them. So they're not going to sort of overtake the dye that you use them with if you do decide to use them in the mordanting process. But anyways, in this example, I used the dried fruits, which you can see here in these bundles in this picture of Rhus copalinum, which is winged sumac. And, you know, it's hard to define what this color is. It's sort of like maybe more of a brown. Here, this bottom piece, the one that looks more like a mauve, that is actually a soy mordanted cotton. So you can see that really shifted the color. That's the only difference between that one and then this top one, which is silk that was alum mordanted. And then these black marks that you can see on this middle one was because I folded this piece of fabric before I dyed it and I clipped it with metal clips. And the metal interacting with the tannins in the sumac made that dark blackish color. And I will be covering some other sumac colors later in this presentation. And again, this is not the only species of sumac that has this. All species of sumac you can get color from their fruits, either fresh or dried, from their bark, or from their leaves. Sassafras, definitely very abundant on the vineyard. It's freaking everywhere. This one also is almost more of a brown, but it's such a beautiful, rich brown. I couldn't not include it, especially because it's so common and abundant here. This is a dye that I made from sassafras leaves. And for this dye, I actually did have to leave it soaking overnight for it to yield these rich colors. When I originally worked with it, I didn't think it was really going to give me anything because it was just sort of giving me this like yellowy dye that didn't seem to be taking to the fabric very well. But once I let it sit overnight, I was like, holy cow, what is this? So you'll see all the way to the left, this one is a lot darker, and that is because I dipped it in iron after. Juniperus virginiana. In dye books, I had seen people use, oh my gosh, plant names always fly out of my head when I'm on the spot, but the other juniper, the one that's more common on the West Coast. But anyways, I decided to use our local species here, which you can find in like sandy areas. You can find them near the beach. You can find them in old fields. They're also sort of scattered around the island and like the East Coast in general. And for this, I did not use the berries. I just used the leafy branch tips. And it yields this pretty light orange color. And then to the left here, you can see if you dip it in iron, you get like a silver gray sort of color. One that definitely everyone has access to is just dried up leaf litter. I was really surprised. I guess I shouldn't have been because, you know, like oaks are full of tannins, but you can just grab leaf litter from outside your house if it's got, you know, particularly from trees. And so this was a mix of different oak species and some maple leaves, and it yields a really rich orange, like bronzy orange color. And I've made a few different items with these leaves, and you can even use really old ones that are like at the end of winter. They don't even have to be, you know, like freshly fallen leaves. And this dye holds up really well because, again, it's like pretty much based on tannins that are in there. And this is another one. Actually, if you look at the background of all of these slides, this picture on the right here of this scarf, I folded and I put it into a different type of dye, which reacted with it, and it made it more of a light peach color, and then gave it these green bands. And if you dip leaf litter dye into iron, because of the tannins, it will turn like a deep gray. Usnea, which is old man's beard, because of the common name, I couldn't help but to include this picture of me from 2 Halloweens ago. But this is a better picture of the plant. Old man's beard, people refer to it as a moss, but it's actually a lichen. And for a lot of lichen dyes, you need to go through a really complicated process of like sort of like someone would make an indigo vat, where you have to find a reducing agent and you have to ferment it and reduce it, blah, blah, blah. But for this, I just did the bark method where, you know, I brought it up to a simmer and then I just let it sit for a day or two. And then I brought it back up to a simmer for a little while and I dyed with it. And it contains something called ooznic acid, which is a dye compound, or can be used as a dye compound. And it yields this sort of peachy, it's more of a light orange than a yellow in person. I tried to get an accurate picture of it. But with something like a lichen, I would say please don't pick it out of trees After a storm, you can usually find it laying all over the ground, and it's better to forage it when it's on the ground. All right, yellows and greens. So a lot of the yellow colors, some of them come from carotenoids, but carotenoids, they don't last very long as a dye. They tend to fade pretty fast on fabric. But flavonoids, on the other hand, they tend to last a little bit longer. Some of them will fade, but especially if you store your fabrics out of light, I've had pretty good success of them staying pretty saturated. And so with flavonoids, a lot of them, you know, they dye yellow, but when they're exposed to a tan or to a iron, they'll turn green. So a lot of the greens that we want to get them from flavonoids because they're longer lasting than something like just chlorophyll itself. There's some dyes, you know, you might get a green result at first, but it'll fade super fast. So in these pictures here, this was from purple dead nettle, which is a really common weed that's like all over the place in gardens. I'm sure I should have included a picture, but I didn't, but you would definitely recognize it. So this one on the left is just alum mordanted, and this one on the right is after it's been in an iron modifier dip. And in general, a good rule of thumb is any sort of herbaceous plant that has a scent to it when it's crushed, like a medicinal sort of scent or like a spicy sort of scent, will probably yield some sort of dye because it's probably got a pretty interesting mixture of plant compounds in it that will yield something, whether it's a phenol or a flavonoid or a myriad of other compounds that are out there. So daffodils, I almost didn't include this one because it's more of a garden plant, but you can sort of find them naturalized sometimes or like growing at the sides of parking lots. Please don't steal other people's daffodils, but if you have some around, they make a beautiful bright yellow dye. And it's really hard to find a good, pure, bright yellow dye because so many of the other plants have some tannins in them or something, which make them like a muddier yellow or more of like a mustardy or like a cloying yellow. But the yellow from daffodils is just gorgeous. And you would make this just the plant tops. You can leave some of the green on it. You don't have to be a purist, just clip them off. And for these, because they're a bit of a hardier flower than most, I would let them soak for a while in hot water, similar to a bark, to really yield the most saturated dye pot that you can. Yellow or curly dock, and this goes for other rumex species. There's other docks out there that you can use. This is not a native plant, and so you don't have to feel bad tearing it out. It's another one you can find in a lot of waste areas, so it's very easy to forage and you don't have to feel bad about it. So to the right here, you can see it's this beautiful like golden mustard sort of color. I love it. And you get this from the roots, which you can see right here. And this was in the original opening slide of the slideshow, but this shows you a cross section. You can see it has this like orange coloration to it. So with this, you just chop it up and you process it like you would a woody material. And then this middle swatch in the picture on the right is dipped in iron. And so, you know, there's different flavonoids and there's different tannins. And so this one isn't quite as green. It's not as dramatic of a green, but it definitely shifted the color green when I dipped it in iron. And you can use the leaves of curly dock, which I haven't done personally, and I don't have a picture of. but the leaves of curly dock should yield a yellow dye, like some of the ones I'm about to cover, that also will turn like a pretty legitimate green when you dip them in iron. So goldenrod is a favorite dye also. I'm going to show you a couple species because they yielded different sort of colored greens to me. This is Solidago gensea. It's super common on the island. And you can see here on the right, in the background here, that sort of tie-dyed looking piece of fabric. The yellow is the original dye, which I'm not crazy about that yellow color, but when you dip it in iron, or you fold it and dip it in iron, like I did with this one, it turns green. And so this green, it's almost leans towards like an olive sort of green. But when I did the same thing with a different species of Solidago, it's more of this, less of an olive green and more of like a, I don't know if you'd call that like a forest green or like a true like green. But again, it's just experimenting. Oh, and actually while I'm here, with goldenrod and with some of these plants, if you do want to get a more bright, clear yellow, the flavonoids tend to come out in a dye bath earlier. So in this sort of case, instead of letting your fabric sit in the dye pot overnight or until it cools, you would want to take it out while it's still a bright yellow color. And then as the tannins later start to come out of the plant, and the other compounds will be when you get sort of a muddier yellow color, like in this picture, which is more of like a boiled egg yolk kind of yellow than like the daffodil yellow. But again, it's just a balance of like a bright yellow versus a more saturated color, and whether you want to dip it in the iron to get green. But it is something to take into account. So we saw that beautiful like reddish color that St. John's wort can give you, but it can also give you this really beautiful green color from the flavonoids that are in it. And so this green, I must have dipped that. No, I actually didn't dip this in iron. That's just from an alum bath. But over here you can see, you know, there's also some yellow here. This is an imprint that I did with the St. John's wort flowers. And you can see all those little dots that I was talking about that have the hypericin in them, which give the red, reddish sort of color. And here it looks pretty dark, but you can still see there's sort of a reddish tinge to it. But I really love the green that I got from the St. John's wort over here. You can't tell very well in the picture, but it was so like rich and vibrant. And again, it's so hard to capture it in a picture, but it was almost like this magical, like mossy, like forest moss sort of green. It was just beautiful. Artemisia vulgaris is another example of a weed that, you know, you crush the leaves and it's really got a strong scent to it, which tells you something. And you can get these results from any species of Artemisia. This is just the one I chose. And this is sort of a noxious, non-native weed that you don't have to feel bad pulling up, and you can probably find on a roadside or in a parking lot somewhere. And this gave more of a khaki army green sort of color that you can see here on the right. Looks like I'm right on time here. I am almost done, but I'll get to the blue greens. So you can also get green by putting some of the bluish colors into iron. So here on the right, I'm gonna cover violas shortly, but this was, you know, you can see like there's some blue here, but there's also this like really cool green color. And that came from adding iron to the blue colored like anthocyanins from this viola. And then on the left here, this is an example of how hard it is to get blue colors. So this is obviously like grayish brown, like a grayish beige and not blue. And so I'm going to show you some berry dyes that gave a good blue dye, but this is a berry dye that did not yield a good blue dye. And so I've gotten good dyes from huckleberries, but blueberries, which are so closely related, gave me this sort of disappointing dye over here. So again, it's so variable. Ligustrum vulgare, European privet, but all of the privets will yield a dye with the berries. So the berry is the part you want for this. I just show you a picture of the leaves too, so that if you don't recognize the berries, you might recognize the leaves, and you can see some of the flowers there in the corner too. You find this all over Vineyard Haven. You know, it's an extremely popular hedge plant to my chagrin, because it's also an invasive species, and birds will eat the berries and poop them out in natural areas, and then you have problems over there. And just because a bird eats berries doesn't mean the berries are good for the birds or the ecosystem. Anyways, you can get, on the left here was alum mordanted fabric, and you can see it gives this sort of oceanic, icy sort of blue that's really beautiful. But it's even better if you dip it in iron and you get these really beautiful, amazing greens. So like this seafoam green here at the front, and then this fabric in the back also, like you can't see it very well, but it's this deep, deep, almost jungle green. And they all came from the same dye bath too. So this is definitely one of my favorite dyes. And I suspect that if it had not been dipped in iron, that this blue color would have faded, because anthocyanin dyes typically fade more quickly than others, especially the berry dyes, it seems. Again, as with other plant compounds and categories, not every anthocyanin is created equal or acts the same. So it could be that this just happens to have a form that tends to stick around. This is black huckleberry. This is a native. So, you know, you don't want to go strip all the huckleberry bushes in your neighborhood of their fruits, because it's really great for wildlife. But look at this stunning dye. And this one, I did not try in the iron for some reason, but it did end up fading to like a more of a silver color. So this one is not very long lasting, but you know, if you were having an event and you wanted to, you know, dye some ribbon, maybe for a wedding, like a something blue, and you got some huckleberries from your property and like made a dot, like made a ribbon that goes around the bride's bouquet or something. I just think it's such a gorgeous dye that even if it's not long lasting, you can still find a reason to use it. But again, if you dip it in iron, then it might last longer. But even though I'm not sure, I still wanted to include it. Viola. So here, these are obviously like garden violas that I have, but this would also work with wild violets. They make an awesome dye, which I wouldn't think would be very long lasting, and it probably wouldn't last like across, you know, as like a generational family heirloom. But mine actually have lasted pretty well with very limited fading, if I just keep it out of the light for the most part. So they will yield depending on the pH, a blue or a purple dye. And so here you can see it's a blue dye that I got. I actually did not make a dye bath with these. These were all from just imprinting them. So I just layered them and then I steamed the flowers directly onto the fabric. And I got this sort of blue color. But this picture here to the right is the same scarf, but like I sprayed it with a diluted vinegar solution and it shifted it more towards purple. So this transitions me into our last few slides, which is purple and gray. It's really hard to get a purple dye like directly from a plant without using iron. This viola is obviously, what's the word I'm looking for, an exception to that rule. But I put purple and gray together because a lot of times the grays can be purplish and the purple and the grays both come from an iron modifying event after the dye bath. So this picture on the left, these beautiful grays, also come from sumac, which you saw earlier, and you will also see again in this slideshow. And these two swatches to the left were in the same sumac dye bath, and I used the immature, like non-woody stems of sumac to make that dye bath. And this one on the left was not mordanted, and this one on in the middle here was mordanted. And then they were all three were dipped in iron. This one all the way to the right was a sumac leaf dye bath, and it was mordanted, and it also is a steely gray color, but it's maybe a slightly different shade. But sumac leaves can also give you, as you can see here, a really beautiful purple. And in the past, I had always gotten more of a purple dye than a gray dye from sumac. And like I mentioned earlier in the presentation, the same plant can yield different dyes, even the same plant part from the same plant, depending on different factors. So I believe that, you know, for the more purple colors that I get from sumac, like this imprint that you see here that I did, those were more mature leaves that probably had different secondary plant compounds in them. Whereas those gray colors were the first time that I had used really immature, sort of still expanding sumac leaves. But yeah, you usually can get this super rich purple color. And you can also get this purple color from something like acorns. And I had mentioned in the flyer for this class that I wasn't really going to talk about oak and acorns because there's a lot of information about it online, but it's such an easily accessible, forageable thing that you can just pick up from the ground that I decided to include it anyways. And so different oak species have different varying amounts of tannins in them. So oak species that have more tannins tend to yield darker, more saturated dyes. So like black oak, for example, is very tannin rich and it's all over the island. I don't remember what species of oak I used for this. It was a few years ago, but here on the right, you can see this one all the way in the back was, well, all three of these were alum mordanted. And this one in the back here is like a beige color, which is a typical color that you would get from acorns. This middle one is from an iron dip that was a bit weaker, and I didn't leave it in the iron solution as long, and you get this purple color. But if you really leave it in, like you either leave it in a really long time or you use a really strong iron solution, you can get this basically black color. And I will say that acorn dye smells amazing when you're cooking it on the stove. It literally smells like maple syrup pancakes or like maple pecan or something. It will make your mouth water. So to finish up, I wanted to give you guys some resources if you want to get into this further. For supplies, I recommend these two websites. And then these books are really helpful. If you're interested in soy mordanting, then definitely check out this second one, which is Botanical Color at Your Fingertips by Rebecca Desnos. She mostly uses soy. This top one, Wild Color, I really like because it goes into a lot of plants, like common plants, and it shows you all the different colors you can get from them, depending on how you treat your fabric. And then this third one, I would only recommend it after you've done some dyeing a bit, not only because it's more expensive, it's like 60 something dollars, but it's really, really goes into some technical details that I think would scare some people away and can seem daunting even to me. But it's a really fantastic book. And, you know, there's probably other great books out there, but there's also a lot of garbage books out there that you can tell someone just sort of threw together, but they maybe aren't that experienced, or, you know, I'm just like, was disappointed flipping through. But this top book would be my top, Wild Color by Jenny Dean, would be my top recommendation for beginners. Geez, I think that's it. And I think I am ready for some questions here. Let's see, this top one.
Oh, you got the questions, Liz?
Yeah.
Okay. Video then. Thank you.
Could you please repeat what you said earlier about flavonoids that shift colors? Okay, so a flavonoid is, it's a secondary plant compound, which basically means that it's a compound that's created by a plant for some purpose that's outside of like super basic survival. So it's created either to, you know, fight disease or protect the plant from radiation or whatever. I'm not a biochemist, and I don't want to try to get into biochemistry details because I'm afraid I'm just going to make a fool of myself and give you wrong information. But flavonoids are usually like a yellow color, or at least a lot of the yellow dyes that we get are from flavonoids, at least ones that I covered in this webinar. And when they are exposed to a tannin, they will shift to a green color. Let's see. So the second one, I'm actually really glad you brought this up because I meant to mention this when I was talking about the violas. But if you have like something delicate like that, you know, might be sensitive to spending a lot of time in water or to heat. So anthocyanins, they will degrade over time to a colorless form the longer they're in an aqueous solution. So the shorter amount of time they're in a dye bath, the better. And so what a lot of people will do is freeze them so that when they thaw, the cells are broken and it releases the color a lot more easily. And so you can access the dye that way faster, and you don't also have to use as high of heat to get the dye. And freezing does not lessen the dye color. So thank you again for asking that. And let's see, do you have a book resource to recommend? So yes. So the book that I mentioned here, the third one, it only mentions it a tiny bit. It doesn't really go into it, but there's another book that is, oh man, I wish I could remember the title. I have it at home. It's like the the science and chemistry behind plant color or something like that. And it's not for dyers necessarily, but it really goes into a lot of the chemistry behind all different colors in plants, whether they yield dyes or it's just from the way the light diffracts between cell layers. So if you email me, I can give you the name of that title. I would definitely recommend it if that's what you're interested in. My email address is elizabeth@polyhillarboretum.org, and I would be happy to share that with you. Unfortunately, a lot of it, you just have to sort of read scientific papers. You would be surprised at how little information is out there on like dye websites and whatnot. A lot of people who are into the dyeing either don't know the science behind it, or for whatever reason, they just don't really put it out there. So when I'm trying to learn about this stuff, I often am just looking up academic papers, and a lot of them are either in the context of like industrial dye processes. And so you have to sort of read between the lines in terms of how you can apply it personally. Or it's not about dyeing at all, but it's more so like you're just reading like some analysis someone did on the leaves for whatever reason. And you can kind of start Googling some of the compounds they come up with, and like looking at like organic chemistry websites. So yeah, that's all I've got for you on that front. But if anyone else has any questions, feel free to unmute yourself and just ask at this point. Otherwise, we can just end it. Or like I said, like feel free to email me.
Liz, it looks like there's one more question in the chat.
That's just someone who was saying thank you.
Or, oh, did you already answer the one above it? Sorry, I missed.
The flavonoids and plant compounds one?
No, the one, so not in the Q&A, but in the chat.
Oh, in the chat. Oh, I don't see, where is my dang chat?
I can just read it off.
Yeah, can you read it off? Because for some reason I don't see it. Maybe if I take, yeah, I don't see the chat.
Okay, so the question is, have you ever used dye for anything else? Art projects like paint, coloring, homemade paper, other?
I have done a little bit on paper. You can like concentrate the dye, and sorry, I'm only pausing because I'm trying to think about if I should try to get into this, or if I should just like route you to some other resources. But basically there are ways you can concentrate dyes, and you can make them into inks. I have concentrated dyes and put them into like markers before. You can actually buy like blank markers that you fill yourself. There's a really good book out there, I think it's just called Botanical Inks, that really gives a lot of great recipes on different like dyes and paints that you can make. And I bought the book last year, and because I'm just busy, I unfortunately haven't had the chance to play with it very much. I have done some imprinting onto paper before. So one thing you can do, and I cover this in my other webinar, which is on our YouTube page, but there's also tons of information online if you just Google it. If you soak plant material in an iron solution for like a day, and then you get some of the excess water off of it, you can imprint it onto fabric or paper. So I have done that before. And, you know, there's so many things you can do. You don't have to dye, you can dye yarn, and then like make fabric, like you can then like, what's the word I'm looking for? Like crochet with it or whatever, or weave, or, one thing I've done too is I've dyed fabric and then I've just taken the iron and I've put the iron powder, just like made like a really strong solution and painted it onto a rubber stamp and stamped with it. You can also dye wood. So like wooden beads people like to dye. You could even try some of these dyes out as like wood stains. But yeah, there's so much you can do with it. And I wish I could give you more info on like making like paints and stuff. But all of that information is in that Botanical Inks book. And also that third book under the book list, that also has some recipes if you're interested. And you can get that from the library here. So if you don't want to pay $60 for the book, get it from the library, make some photocopies. Was that it, Liz, from the chat?
Yeah, so I think we're all set. I'll turn on my video quick. All right, so yeah, thank you so much, Liz. That was great. And I saw a lot of thank yous in the chat and the Q&A, so that was awesome. And thank you everyone for joining. I put Liz's email in the chat if you missed it. And you can also email me if you have any questions, or I think you all should have the slides, but if one of you didn't get the slides, or if you have any questions, you can email me at lizladwig, LADWIG @polyhillarboretum.org. I'll put that in the chat too, or you can email the other Liz. So thank you everyone for joining, and I hope you all have a great rest of your evening.
Thanks everybody. It was really fun for me at least. I hope you guys got something out of it. Bye.
All right, thank you. Bye everyone.